Excuse me, sir. Which road should I take to get back on the highway?
Well, solve for the acceleration of a cannonball going towards Earth and the acceleration due to gravity.
I'm Introvert Studios and welcome to Science Bit. That very real-world outcome of not knowing where to find the highway because the person who told you wanted you to do math first. This one says a 2,000 kilogram car is parked on a 70-degree slanted hill. Draw a free body diagram and solve for the magnitude of all the forces acting on it and the coefficient of friction. So we're gonna go ahead and draw the darn thing. I said darn. This is exactly 70 degrees. No, it's not. But we're gonna call that that. And the force of the car is pulling it toward the ground. However, it is parked, so all net forces are at 0. So everything is balanced. Means F of F, they equal the inverse of each other. We'll get more on that later. But we have more forces acting on it, like the force of gravity, and the force, and the normal force. So, here's what we know. We know the mass equals 2,000 kilograms. We know acceleration due to gravity, this is gravity, is negative 9.81 meters per second squared. We know that theta, where theta? Oh. That theta here is 70 degrees. Now, what we don't know is the force of the car, the force of gravity, the force of friction, the normal force, or the muse. So now what we want to find the force of gravity. By doing that, we're going to use F equals ma. So m being 2,000 and a being negative 9.81 meters per second squared. Now with editing magic, I have this cool new desk toy and the answer. How many newtons? So that is our force of gravity. So force of gravity equals negative 9,620 newtons. Now, you see how there's an arrow going right at force of gravity that's supposed to be equal and opposite of the force of gravity? That means that the normal force is 19,620 newtons. It's the inverse of this. Now we just need this or this. I'm going to pick this because it's going downward. We already have this. So, essentially what this is saying here is that this is drawn wrong. Pardon. Is that, let's get a little close up on this. Force of gravity, force of the car. Does this look like something to you? Well, it should. It's a triangle. Yeah, this triangle here. I'm sorry, I must be coming down with something. This triangle here is important because we can use sine. Yay! Sine is opposite over hypotenuse. So sine theta equals force of gravity over the force of the car. Now I want to multiply this to get rid of this, because multiplication is the opposite of division. So it's going to be sine theta multiplied by FC equals FG. Well, we already know FG, so what we want to do is get this over here so it's not bothering this. And we do that by dividing. Notice how we divide it, it becomes the denominator. So we just plop this over here. This cancels out over here. We just plop it over here. So force of the car will equal force of gravity over sine of theta. And with editing magic, I have this cool hat and the answer, which is negative 2087.9.17. So we have the force of the car, which is the big number I just said. So that means we also have our force of friction holding the car there, which is going to be the opposite, so it's going to be a positive 2087.9.17. So now all left to do is find the mu. So mu, I believe, equals, equals the force of friction over the normal force. So mu equals this big boy number over this small number. With some editing magic, I have the answer, 1.1, and flashbacks from my time in the war. Thank you for watching Science Bits. It's a cookie.